This example 2.2a. Okay, solve for each of the following inequalities. Okay, so do the same thing. Okay, simplify and solve for x. Okay, so you have 5x plus 2x is less than or equals to 16. Okay, combine your or simplify your left hand side. You get 7x less than or equals to 16. Okay, divide the 7 over. Okay, because it is a positive number that I'm dividing by. Okay, do not flip the sign. Okay, then you leave it in proper fraction. You get x less than or equals to 2 over 7. Okay, so the greatest rational number would be, okay, because there's an equal sign here. Okay, rational number means numbers that can be represented in fractions. Okay, so since there's an equal sign here, okay, the largest value I can get would be 2 over 7. Okay, but if I ask you for the greatest integer, which is the whole number, okay, is less than or equals to 2 over 7, which means the greatest integer I will have will only be 2. Okay, so same thing for the example below for part B. Okay, x minus 3x less than or equal to 7. Okay, simplify, I got minus 2x less than or equal to 7. Okay, bring the 2 over, because you are dividing by minus 2, you flip the sign. Okay, our final answer is x more than or equals to minus 3.5. Okay, so the smallest rational number would be same thing. Okay, rational number is your fractions, right? So it will be minus 3.5. Okay, but if I ask you for the smallest integer, okay, so because this is a negative number, be careful. Okay, so because it's more than or equals to minus 3.5. Okay, if you remember on your number line, okay, minus 4, minus 3. This is minus 3.5. If I'm more than this, more than or equals than this, okay, the smallest integer I will have will be minus 3. Okay, so minus 3. Okay, so now if we look at example 2.2b, okay, solving inequalities and integer and representing them on the number line. Okay, so now we combine everything that we have learned so far. Okay, so solve for the inequality, you get x less than or equals to 4. Okay, so remember when I went through this portion on number line, okay, it is a shaded dot, right? Because why? There is an equal sign here. Okay, so let x less than or equals to 4. Okay, less than on the left hand side. Okay, arrow to the left. That's it. Okay, so we have less than or equals to or more than or equals to. It is a shaded dot. Okay, it's more than or less than. Okay, it's a hollow circle. Okay. Okay, now we move on to the next page. Okay, so this is just a further example which is a bit more complicated. Okay, solve the inequality and illustrate the solutions on the number line. Okay, so this scenario is when you have numbers on both your left hand side and the right hand side, which means on the left hand side you have inequality, on the right hand side you have inequality as well. Okay, so you see from the first step to the second step, they just combine the middle. Okay, 4x plus x, 5x. Then what you do on x, right, I divide 5 throughout on my left and my right. Okay, you end up with this final inequality. Okay, so recall what I went through with you earlier. Okay, this is just a more than sign, so it is a hollow circle. Okay, this is a less than or equal sign. It is a shaded circle. Okay, so you have the two values here. Okay, then you just draw the two dots. Draw one hollow circle and a shaded dot. Okay, then join the lines. That is it. Okay, so in this case, because they ask you to indicate 0, that's why you put a 0 here. Okay, but in the examples earlier I went through with you, there's no such condition. Okay, that's why we didn't have to put a 0. Okay, for part B, part 1, okay, using our answers in part A, write down the largest rational value of x. Okay, so largest value will be 4, right? The rational value as well. Okay, because I cannot go anywhere or anywhere above 4. Same thing for largest integer value, also 4. Okay, the largest prime value of x, which means prime number, okay, is 3. Okay, because your prime numbers start from 2, 3 onwards. Okay, please remember that 1 is not a prime number.